We're going to start talking about sequences. So in this unit, there's things called sequences and things called series. And we're going to deal with both of them, but we're going to start off with the most simple, which is arithmetic sequences. And here's an example of a sequence. We have the numbers 3, 5, 7, 9. Each of these numbers are called terms. So this would be the first term, second term, third term, fourth term, etc. And if you hear the word term or element or member, they all mean the same thing, but we're usually going to be using the word term. These little three dots here means that this sequence goes on forever. And obviously we're not going to list out all of those numbers, so we use those 3 dots. In your AOPS algebra book, you can look on page 589 and define these two following because we need to know the difference between them. In general, a sequence is a list of numbers, and technically they could be objects or pictures, but we're going to be mostly dealing with numbers. A list of numbers in a special order. The order matters. So just a list of numbers in a special order. And then a series is slightly different. It is the sum of all the terms in a sequence. So a sequence is just a list of numbers, and then a series is I take all of these numbers and add them together. Now, in sequences, if we kind of take a general idea of a sequence, there are many different types of sequences. Sequences, they can be finite, which means there's only a certain number of terms, it ends, or they can be infinite, which means they go on forever. As far as sequences go, you can have arithmetic sequences, which is the type that we're going to talk about first. You can have geometric sequences, which we'll talk about next. You can have other types of sequences, maybe like exponential or things like that. We're not going to talk about these because we just don't have the tools yet to deal with them, but they do exist. And you can have like sequences that really have no pattern at all. Like the arithmetic and geometric are going to have a special pattern and you're going to see it easily, but there are sequences that exist that have no pattern at all. But generally we're going to deal with these two, arithmetic and geometric, because we can make equations out of these, and in math we love to make equations. So we're going to deal with those. All right, so let's go ahead and we're going to start concentrating on the arithmetic sequence because it is the most simple. So an arithmetic sequence, here would be an example of a simple arithmetic sequence. -6, 1, 8, 15, and 22. It's a finite sequence. It has 1, 2, 3, 4, 5 terms. And so here's a kind of a definition or some things that we know about an arithmetic sequence. It's a special type of sequence, and we know that the numbers have these kind of things. The difference between consecutive terms, so terms that are one right after another, is constant or it stays the same. So for example, if I take the second term minus the first term, I would get 7. If I take the third term minus the second term, I would get 7. Fourth term minus third term, I get 7, so on and so forth. So the difference is the same. Another way of looking at it is that every term is either added or subtracted by the same constant number, or you could say it increases or decreases by a constant amount. So in this example, from the first term to the second term, I'm adding 7. From the second term to the third term, I'm adding 7. Each term is being increased by 7 in this particular case. So one thing that you need to know how to do is just recognize an arithmetic sequence. So which of these are arithmetic sequences? So let's take a look. Number 1 here, I go -3 to 1 to 5 to 9. Oh, I recognize that each term is being increased by 4. So I know that that is an arithmetic sequence. 2, I go 1, 2, 4, 8. Well, that's being increased by 1, by 2, by 4. That is not an arithmetic sequence. That's actually being multiplied. Each term is being doubled. So that is not an arithmetic sequence. It's actually a geometric sequence, which we'll talk about later. So 3, I go from 4 to -12 to +36 to -138 That is closer to geometric as well. It's kind of being multiplied by -3. So that is not arithmetic. And then 4 up here, I'm being increased by 7 each time. So 1 and 4 are arithmetic sequences. So that's a pretty easy thing to just identify, is this an arithmetic sequence or not? So we'll turn the page on our notes. If you have an arithmetic sequence, there's a special formula that we can use to predict all of the different terms in our arithmetic sequence. And we love equations, they make life easier. So the formula that we are going to use is this. The formula for the nth term, and this is just a fancy way, this nth term is just a fancy way of saying whatever term you want to figure out, you can figure out. If I want to figure out the 13th term, the 27th term, the 1013th term, I can do it. So the formula to find the nth term in an arithmetic sequence is this. A to the n, which is the nth term, is going to equal a, which is the first term, times n minus 1, n is your number of terms, times d, which is the common difference. You might also see it as in more of a function notation. This also just means the nth term, whatever the nth term is, equals your first term plus the number of terms minus 1 times the common difference. And let's go ahead and practice that. You can take a look in your AOPS book to page 591 and go to this problem, and you can see how the formula is created and why it works, and you can write some notes below. But we're going to go ahead and go on with practice. So here's an example here. Find the 14th term of this arithmetic sequence. 4, 7, 10, 13, and it's going to go on forever. So I need to identify a couple of things over here. I'm going to identify my first term. That's going to be A. So my first term is 4. I need to identify my common difference, or what each term is changing by. So in this case, each term is being added or being increased by 3. And the nth term, I'm wanting to find the 14th term, so n is 14. So I plug those into my formula. First thing is just write out the general formula, which will help you memorize it. Plug in what you know. The 14th term, which I'm trying to figure out, is my first term plus 14 minus 1, because 14 is my term I'm trying to find, 14 minus 1, times my common difference, which is positive 3. I get 4 plus 14 minus 1 is 13 times 3. 39 plus 4 is 43. So my 14th term, if I were to continue to write out this, this geometric sequence, would be 43. I could go ahead and just write out the sequence, adding 3 each time until I get to the 14th term, and I would get 43. But a lot of times using this formula is a lot faster. So let's go ahead and do a couple practice problems. We'll do a couple of these, and then I will let you work on the rest of your packet. So here we go. The first thing, which I want you to do, is just write out the first term and the common difference, because that's the first thing that you really need to notice whenever you're doing a problem. Then you're going to go back and practice writing out the general formula, and then you can use that formula to find the 20th term. So here we go, in example number 2. Well, the first term is A, so that's negative 190. And my common difference, how am I going to each term? Negative 190 to negative 290, that's each term is being subtracted by 100. So that would be the first thing that I would want to do. Okay, then I'm going to go ahead and find the general formula. Well, I know, and I'm going to do my work over here. I know that my general formula is, I'm going to write it out just to practice. A to the n is my first term plus n minus 1 times my common difference. Okay, so a to the n is, I don't know that. This is going to stay just a to the n. My first term I can plug in. I'm going to keep my n minus 1 because, again, my general formula is trying to figure out the value for whatever n is, so I'm keeping n in there. But then I can multiply this by my common difference, which is 100. And there's a couple different ways I could write this. I could rewrite it as a to the n equals negative 190, and I could just write it like this, n minus 1 times negative 100. I want to make sure that negative 100 is in parentheses, so we know it's being multiplied, not subtracted. Or if I wanted to do my coefficient at the beginning, I could do that. And this is a negative 100, so this becomes minus 100 times n minus 1. These are the exact same thing. This second way might look a little bit neater, but either one is fine. Let's go ahead and do number 3, and then you can get time to practice the rest of these. All right, my first term is 77. My common difference, how do I get from 77 to 105? Well, 105 minus 77 is 28. So I'm adding 28 to each one. Okay, so now I'm going to go ahead. Oh, I didn't find the 20th term on that one. I'll do that one in a second. But I'm going to go ahead and find the term here. I'm going to write my general formula. Helps me memorize it. Then I'm going to plug in what I know. First term is 77, and my common difference is 28. So I could either leave it like that, or I could write it where I put the 28 in front. Okay, so there's my general formula. Now I'm going to go back and find the 20th term because I forgot to do that. That's pretty easy. So up here, I'm going to find the 20th term. So A and my 20th term, that's how I'd label that, is negative 190 plus 20 minus 1 times negative 100. And I'm just going to go ahead and plug that in my calculator. Negative 100 times 19 minus 190. That in my calculator turns out to be negative 2090. So if I were to continue out this formula with 20 terms, my 20th term would be that. Same thing here with number 3. My 20th term, n is 20. 20 minus 1 times 28. I'm going to plug that in my calculator. 28 times 19 plus 77. That turns out to be 609. So if I were to continue out this sequence, the 20th term would be 609. Go ahead and work on numbers 4 through 9. They get a little bit more tricky with decimals and fractions and square roots. But again, you're still looking for your first term. How is your first term changing to the second term and so forth? Each one should be the same common difference. Plug them into your formula. Your formula might look a little more funky with fractions and decimals and exponents, but it'll still be the same thing. And then use it to find your 20th term. And then you can correct your work on our Schoology site before we go on. I'm going to go ahead and I'm going to pause. So pause this video, do those, and then I'm going to go and do numbers 10 and 11. All right, hopefully you paused the video and you checked numbers 4 through 9. If you haven't, you can do that sometime, but I'm going to go ahead and do numbers 10 and 11. So now we're going to go backwards. We're given the equation, the formula, and we have to find the sequence. And we're just going to find the first 4 terms because we don't need to find more than that. Okay. So a to the n equals negative 23rd plus 17 times n minus 1. Using my formula, I know that this is my first term, and I know that this is my common difference, and that is positive. So my sequence is going to start with negative 23, and each of the terms is going to be increased by a positive 17. So I'm just going to start with negative 23, and each term is going to be increased by 17. So negative 23 plus 17 is negative 6. Negative 6 plus 17 is 11. 11 plus 17 is 28. And I could continue that forever, but I just want to find the first 4. And do you notice anything? Well, I don't know, that's my first term. Each one is being increased. I could have used my, my equation, and I could have plugged in 1 for n and gotten that. If I plugged in 2 for n, I would have gotten -6. If I plugged in 3 for n, I would have gotten 11. If I could plugged in 4 for n, I would have gotten 28. So I could have found these by using my formula, or I can just start with the first one and then add as I go. You can go ahead and do number 11. So pause the video, do number 11. All right, the answer to number 11, we start with 15, that's our first term. So there we go. Each term is being decreased by 5. So I think it's much easier just to start with that and then go down by 5. So 15 minus 5 is 10, minus 5, minus 5. And we could do that forever. Obviously, the first 4 is super easy to do on your own. If I had to find like the 1000th term, I would definitely use my formula because it's a whole lot easier to do that. We are going to do number 12, 13, and 14, and that will conclude this video. All right, 12, 13, and 14 is very similar to what we were doing before. We want to write the general form or the equation for this sequence. Well, let's see. I'm going to identify my first term is 78. My common difference, 78 to 105, I'm adding 27. And sometimes it's nice to just make sure you're right. Is 105 plus 27, 222? Yes, it is. Okay, so I'm going to start. A to the n, my nth term is going to be my first term. Plus, I like to write my common difference. I usually like to write that first. I think it looks nicer. Times n minus 1. Number 13, I'm going to identify my first term is 18. My common difference, 18 to 25, I'm adding 7 to each term. So my equation, my nth term is going to be my first term plus my common difference times n minus 1. And last but not least, my first term is -14. My common difference, I'm going from -14 to -30. I'm going down. I'm actually being decreased by 16. So my equation, my nth term is my first term. My common difference in this case is -16 times n minus 1. And I could have written it as my first term plus n minus 1 times -16. I could have written it like that, but I just think this is a whole lot neater and easier to write. All right, if you haven't, finish up with numbers 1 through 14 and check your answers. And then our next video will start with 15, and those are problems that are still using the general form, but going a little bit more in depth.